Hey YouTube, how's it going? So today, as the title says, we're going to be finding, proving, deriving, whatever the cubic formula. I'm going to try to keep this as short and sweet as I possibly can to give a concise explanation without missing out on too many of the important parts. There will be timestamps and in the description and on the timeline. So without further ado, let's just get started. So here we have the cubic equation ax cubed plus bx squared plus cx plus d equals 0. You can plug in real numbers for these coefficients and it'll give you a cubic equation. So the first thing we're going to do to get started on this proof is substitute x, get the marker, substitute x for y minus b over 3a. That means that y is equal to x plus b over 3a. And what this is going to do when we substitute this in, it's going to get rid of the quadratic term here. It's going to get rid of the x squared. It's called depressing the cubic. That's what it's called, depressing the cubic when we do this. If you want to know more about why we're choosing this specific number, check the description so I can keep this moving. So what we're going to do, we're going to substitute x for y minus b over 3a, and that gives us this beautiful equation right here. At this point, we're going to want to find y minus b over 3a cubed and y minus b over 3a squared. So we're going to find those values here. I'm skipping through all the algebra to keep this moving fast. If you want to do the algebra yourself and check it against my answers here, you can do that, obviously, but it should give us these answers for the squared and the cubed. So we're going to put these back in, and it gives us this equation now. So from here, we're going to divide by a to get rid of this a term in front of the y minus b over 3a cubed. So if we divide by a, it becomes b over a, c over a, and d over a, and 0 divided by anything is just 0, so it keeps the 0 term. And after this, we're going to go ahead and distribute this b over a out to each of these terms, c over a out to each of these terms, and then keep these two terms here. And that's going to give us this behemoth of an equation. Again, doing algebra, I'm skipping past that. You can do this, check your answers here if you'd like. But if we combine like terms, it's going to give us this slightly more bearable equation right here. Y cubed minus b squared y over 3a squared plus cy over a plus 2b cubed over 27a cubed minus bc over 3a squared plus d over a equals 0. So what we're going to do now is factor out a y here for these two terms. So yeah, we're just going to take out this y here, put on the outside, put parentheses, and that's going to give us this at the top here. So as you can see, we now have y cubed plus a coefficient times y plus a constant. And if you notice, there is no y squared here. There's no y squared. We've gotten rid of the, y squared or the x squared term. So now now we have a depressed cubic. So we're going to let p equal this here and let q equal this here to simplify this equation down. And that gives us this very nice, simple equation, y cubed plus py plus q equals 0. So from here, we're going to substitute another thing for y. We're going to let y equal f plus k. Okay, so whatever y is, f plus k is equal to it. So we're going to, oh yeah, right. So now, obviously, we have to find what is f plus k cubed here. So once we do that, we get f cubed plus k cubed plus 3f squared k plus 3fk squared. So after this, what we can actually do is we can keep f cubed and k cubed, and here we can actually factor out an f and a k from both of these, or a 3fk, and that's going to give us 3fk times f plus k. Because if you FOIL this out, it becomes, let me just grab this, 3fk times f becomes 3f squared k, 3fk times k becomes 3fk squared. So these two terms are equal to each other. So what we can actually do from here, if you think about this, these two equations, well, not really equations, expressions are equal to each other. Therefore, if we were to take this top one, f plus k cubed, and subtract this whole thing here, it would equal 0 because they are the same. So if we subtract this from this, it will give us 0. So when we do that, we get f plus k cubed minus 3fk squared times f plus k minus f cubed minus k cubed all equals 0. So we're just doing that. Now, if you notice, y is actually equal to f plus k. We said that earlier. Y is equal to f plus k. Let me just make this neater. So this here becomes y cubed. This here becomes y, so it becomes minus 3fk times y. And, well, this just stays the same, but we're going to change it into this to make it easier to tell what's going on. So this is now y cubed minus 3fky plus negative f cubed minus k cubed equals 0. And that's what I have here. And if you notice, we also had the equation from earlier, y cubed plus py plus q equals 0. So now that these both equal 0, both equations are equal to the same thing, we can say that the equations are equal to each other. And if you look, we have a y cubed, and then we have a coefficient multiplied by y, and then a constant equaling each other. Therefore, we can say that this coefficient p is equal to this coefficient, negative 3fk, and we can say that q is equal to this constant, negative f cubed minus k cubed. We're going to do a little bit of algebra here, which I will explain why we're doing this in a second. But we can make f cubed plus k cubed equal to negative q. We're just factoring out a negative there and dividing it. This one, the p, we can set equal to p, or negative p over 3 equals f times k. And then we're going to cube both sides here, and it becomes negative p cubed over 27 is equal to f cubed times k cubed. So these are our two equations that we're left with. F cubed times k cubed equals negative p cubed over 27. F cubed plus k cubed equals negative q. So from here, we're going to use two different methods of doing the next step. It's going to be I'm going to put the timestamps in the description for these two methods. One is going to be by algebra, one is going to be by Vieta's theorem. I'm just going over both because they're slightly different and they may make sense more, different ones might make more sense to different people. Sorry. So I'm just going to do both. Again, I'll put timestamps. I'm going to do algebra first. But what we're going to do here, let me just check the next page. Right. So we're going to substitute f for in terms of k and q. So using this equation here, we're going to set f cubed equal to negative q minus k cubed. So from there, we're going to substitute this value of f cubed in here. So it becomes negative q minus k cubed times k cubed equals negative p cubed over 27. We're going to distribute this out, and it gives us this equation on the next page. Negative k to the power of 6 minus q times k to the power of 3 plus p cubed over 27 equals 0. After we subtract this p cubed over 27 to the other side. We're going to factor out a negative, or divide out a negative there to make it an easier equation. K to the power of 6 plus qk cubed minus p cubed over 27 equals 0. And then we're going to make a new variable called u equal k cubed. And that actually gives us a quadratic, u squared plus qu minus p cubed over 27 equals 0. So from there, we're going to use the quadratic formula, if you guys remember from Algebra 2 or whatever, x equals negative b plus or minus square root b squared minus 4ac over 2a. and we're going to use these coefficients. And that will give us this quadratic equation right here. U equals negative q plus or minus square root q squared plus 4p cubed over 27 all over 2. So the u here is equal to k cubed. So we can say that k cubed is equal to this. Let me just check the next slide. Right. And if you remember, we substituted f cubed for negative q minus k cubed. So if we know now that k cubed is equal to this, we can say that f cubed is equal to negative q minus all that. So this is really, let me get my marker here. So this is really negative q over 2 plus or minus this over 2. And these two negatives are going to cancel out into a positive. So what it's going to end up becoming is negative q plus q over 2 plus or minus all this. And when you have negative q plus q over 2, it's just going to become negative q over 2 again. So it becomes negative q over 2 plus or minus square root, blah, 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 4p cubed over 27 all over 2. And what you'll see is f cubed and k cubed are the same. F cubed equals this, and so does k cubed. So now we have f cubed and k cubed equaling these two things. I believe, yeah. So the next page, f cubed and k cubed, they both equal this, where they are different because of these two signs. So if f cubed would have the plus sign, k cubed would necessarily have the minus sign. And we're just going to get rid of these cubes here by cube rooting both sides, and that gives us f and k equals this mess. So that is the algebra method. I'm going to move on to the Vieta's method. If you want to see the Vieta's method, you can just keep watching. If you want to skip, you can look at the timestamp. But yeah, I'm going to move on to the Vieta's method now. Okay, so now we're on to Vieta's theorem. So I'm going to quickly explain what Vieta's theorem is. If you already know or you don't care, you can just skip past to the actual execution of this, but I'm going to explain it real quick now. So what Vieta's theorem basically says is it's the relationship between the roots and the coefficients of a polynomial. We're just going to work with a quadratic here because that's how we're going to implement it into our proof. But basically what it means is, okay, let's factor this quadratic equation here. We're going to use the factor sum method. It becomes x minus 3 times x minus 2 equals 0. And in this case, x has to be 3 or 2 in order for this equation to be 0. So those are our two roots, 3 and 2. What Vieta's theorem says, it says that the sum of the roots, this is in a quadratic equation, sum of the roots is equal to negative, I'll explain this in a second, negative a n minus 1 over a of n. So what that means, a of n minus 1 is just gobbledygook gibberish, but it means the second degree coefficient here. So a of n would be the first coefficient of the polynomial. In this case, it's 1. There's a secret 1 hiding here. Sorry. Yeah. So a of n is just 1, and that would mean that a of n minus 1 is negative 5 right here. So we're going to take the negative of negative 5, which is of course just 5, and we're going to divide it by a of n, which is of course 1. 5 over 1 is just 5, so it should be root 1 plus root 2 is equal to 5. Well, these are our roots, 3 and 2. 3 plus 2 does equal 5, so it works. That's what Vieta's theorem says. There's one other one for multiplying, root 1 times root 2 is equal to a0 over a of n, a0 over a of n. So again, a of n is the first coefficient here, and a of 0 is the constant. So a of 0 is 6, and a of n is 1. 6 over 1 is just 6. Root 1 times root 2 should equal 6. Well, our roots are 3 and 2, so 3 times 2 should equal 6, and that is, of course, true. So that's what Vieta's theorem says. It's a product sum theorem for the roots, and we're about to implement it here in a second. So that's the explanation. That's the end. Okay, so we are going to make a quadratic. This is the execution of Vieta's theorem. So we're going to make a quadratic based off of assuming that the roots are f cubed and k cubed. That's the roots of this quadratic. We're going to, let me just move to the next page real quick. Okay, yeah. So we're going to make a quadratic where the variable is just u. This has no relation to the u that we used in the algebraic method. It's just a new variable I'm using. So going off of Vieta's theorem, it says that when you multiply the roots together, it's going to be the coefficient divided by the coefficient of the constant, in other words, just the constant, divided by the coefficient of the first term. So we can go ahead and actually assume that the first term is 1. Let me just write this out. Root 1 times root 2 is going to be f cubed times k cubed, and root 1 plus root 2 is going to be f cubed plus k cubed, right? Obviously, because these are the roots. So by Vieta's theorem, root 1 times root 2, which is just f cubed times k cubed, is going to equal a of 0, which is the constant, over a of n. And root 1 plus root 2, which is, of course, f cubed plus k cubed, is going to equal negative an minus 1 over a of n. So we can go ahead and actually assume that a of n here for both of these is just 1. It doesn't matter what you say it is as long as you keep a of n the same for both of these equations. So we're going to assume it's 1 to make it easier on ourselves. But what that means is that f cubed times k cubed is just going to be the constant term, and f cubed plus k cubed is going to be the negative of the second to last term. So that's going to give us a quadratic that looks like, well, what is f cubed times k cubed? Well, f cubed times k cubed is negative p cubed over 27. That means that the constant is going to be negative p cubed over 27. The second to last term, or in this case, just the normal x term, is going to be f cubed plus k cubed, or the negative of it. Well, we know that f cubed plus k cubed is negative q, and because f cubed plus k cubed is the negative of the second coefficient, we know that the second coefficient must be just normal q. And we already said that the first coefficient will be 1, so, sorry, this becomes u squared plus qu plus negative p cubed over 27 equals 0. So we're building a quadratic. We have that on the next page here. And we're going to use the quadratic equation to find that u is equal to negative q plus or minus square root q squared plus 4b cubed over 27 all over 2. And we know that the roots of this equation, as we said before, are just f cubed and k cubed. And this quadratic gives us the roots. So we can say that f cubed and k cubed are equal to this equation, where they are different in terms of this plus or minus sign. So if f cubed is plus, k cubed is going to be minus. And then we're just going to cube root this whole thing to get rid of these cube signs. And we get f and k is this gobbledygook, right? So that's the Vieta's theorem method. At this point, in the video, whether you go by Vieta's theorem or algebraically, we should have this equation. F and k equals the cube root of that. I'm not going to say it again because I've said it multiple times, but F and k are the that equation. So we're going to we're going to remember back that y is equal to f plus k. So if y is equal to f plus k, well, we can just say that f plus k is this uh, plus itself, except, we're going to make the plus and minus signs different. So that gives us this equation here. We're getting to the home stretch here, guys. If you remember back all the way at the very beginning, we set x equal to y minus b over 3a. And that means that y is equal to x plus b over 3a. So we're going to substitute y in here for x plus b over 3a. And then we're going to subtract b over 3a from both sides. And that gives us x is equal to this whole disgusting thing, minus b over 3a. And there we go. We have isolated x. The only thing left to do is to substitute the q and the p back in, and then we will have our final answer. So if you remember all the way back, I'm just going to write it down before we finish here. P is equal to negative b squared over 3a squared plus c over a. Q is equal to 2b cubed over 27a cubed minus bc over 3a squared plus d over a. And if we substitute this all in, I'm not going to do the algebra because that takes way too long. I have it pre-written here. We get this final monstrous equation. This is the final cubic formula. I'm going to try to say it out right now. But this is the final equation. This is the cubic formula. And that's how we do it. I'm going to go ahead and say it so I can say QED at the end. We have x equals the cube root of negative 2b cubed over 27a cubed plus bc over 3a squared minus d over a plus the square root of the square root quantity 2b cubed over 27a cubed minus bc over 3a squared plus d over a squared plus the quantity c over 3a squared minus b squared over 9a squared cubed all over 2 plus the cube root of negative 2b cubed over 27a cubed plus bc over 3a squared minus d over a minus square root quantity 2b cubed over 27a cubed minus bc over 3a squared plus d over a squared plus quantity c over 3a minus b squared over 9a squared cubed all over 2 minus b over 3a QED. We have finished the cubic formula, and that is it. So thank you guys for watching. That's the cubic formula, and I'll see you next time.